Hello viewers, today our topic is circle diagram of induction motor. So first step 1 is how to draw the circle diagram. So in that first step is take y-axis. In y-axis is voltage and x-axis is current. So so to draw the circle diagram we need no load test, no load and block rotor test. We need no load and block rotor test. Both those tests are required to draw the circle diagram. So first of all, by using no load test, we can find W naught and I naught and V in one. So wattmeter, ammeter, and voltmeter readings, and from that we can find. So this is cos phi naught. So cos phi naught, and also we can find phi naught. Phi naught, which is cos inverse of this value, cos inverse of this value. So and then so we got phi naught and I naught from ammeter reading. So ammeter reading. So generally, if you want to draw something, we should take the scale. We should take the scale. So generally, this is drawn on graph, graph sheet, graph sheet. So that graph sheet contains some blocks. So in that one unit, so in that one unit nothing but 1 centimeter. I took 1 unit 1 centimeter is equal to 2.5 amps. So 1 unit indicates how much? 2.5 amps. So I assumed current is 5 amps. I not no load current is 5 amps. So this is just for assumption. According to the readings we should take. So 1 centimeter is equal to 2.5 amps. And then 5 amps is equal to how many centimeters? 2 centimeters. 2 centimeters. So by knowing these two data, that is nothing but I naught and phi naught. So we should draw this one. So with an angle phi naught, so we will get some angle. This is phi naught with an angle phi naught. We should draw I1. So this the length of I1 is how much? Here we got 2 centimeters. So this length should be the length should be 2 centimeters. With the length of 2 point centimeters with an angle, we should draw I naught. And from this point, draw a parallel line to the x-axis. This indicates constant losses. This is the first step to draw the circle diagram. Next step is, so from the no-load test, we drawn I naught, and from the block rotor test. From the block rotor test, we will get cos BR, nothing but block rotor power factor. From this, we can find phi BR, phi BR, which may be some angle, which may be some angle. And so from block rotor tester, ammeter reading indicates the IBR. I assumed that as 25 amps. So previously I took the scale 1 centimeter equal to 2.5 amps, and then 25. So 25 amps is equal to how much? 25 by 2.5, which is equal to 10 centimeters. So now 10 centimeters. Now with an angle phi BR from this one, with an angle phi BR, this one, with the length how much? This is the phi BR length. This is the length how much? 10 centimeters. We should draw the line with an angle phi BR. So generally phi naught is greater than phi BR because this is the no load power factor. This is the no load power factor phi naught. At no load, it draws more current to which is useful for the produce the flux in the air gap. so that is reactive in nature. That's why phi naught is greater than the phi br. Okay, now phi br, with the by phi br we drawn 10 centimeter line. So next we should draw a line in such a way that should connect I naught and phi br like this. We should draw a line like this. This line is called output line. So I will discuss later why this is output line. So this line is called ABE line is called output line. This is the second step. So by using no load test, we drawn I naught, and by using block rotor test, we drawn a line and I connected A, B, those two lines. This is called output line. So next third step. So we got this line and this line and this line. We drawn these three, and now so from A to B. So A to B, a line is there. So from this AB, we should take more than half length of AB. So this is more than half. So from this more than half, A as a center, draw an arc here and right side, and B as a center, we should cut the same or those lines. So simply we should bisect the AB line. So to bisect the AB line, we should cut this line like this, and draw a join these points, join this point and this point by joining middle line. That is nothing but this is horizontal line. We should extend up to this one with an angle how much? 90 degrees. With an angle 90 degrees. So don't forget this is 90 degrees. By keeping 90 degrees, we should connect this point and horizontal line. Now with the center C and AC as a radius, draw a semicircle like this, which joins B like here, like this. We should draw. After drawing semicircle with the center C and A of this semicircle, and from this point B and extend a line up to x-axis and join B and G. Generally, so GEF indicates nothing but constant losses, constant losses from the no load test, no load test. And then B to F distance gives us variable losses, nothing but copper losses. Copper losses, which is the sum of stator copper losses plus rotor copper losses. B to F is gives the Blockwood rotor test value. The Blockwood rotor test nothing but to find the copper losses. So wattmeter reading gives the copper losses. So BTF distance is gives the variable losses. Variable losses. Generally, variable losses is the sum of stator copper losses plus rotor copper losses. This is stator copper losses. EF is the stator copper losses. B2 E is the rotor copper losses, and B2E. B2 is the rotor copper losses. E2F is the stator copper losses. Why we should take EF as stator copper losses means generally after no load test, at no load test, the stator doesn't draws more current. So if you give the load, if you put the load, the stator draws more current and copper losses takes place. So after copper losses in the stator, the rotor stator copper losses, the stator winding produces more flux, and those flux will be cut by the rotor, and then rotor current will produce. Due to the rotor current, rotor copper losses takes place. That's why first initially stator copper losses takes place and then rotor copper losses takes place. That's why first length B2EF gives the stator copper losses. Let's clear this one. So generally E2F gives us a rotor stator copper losses. E2F gives us stator copper losses and E2B gives us, so this is nothing but up to this one, stator stator copper losses, and this one gives a rotor copper losses, WCU copper losses. And so I told E point this divides the total copper losses into rotor copper losses and stator copper losses. This is stator copper losses and rotor copper losses. And how to locate E? First of all, how to locate point E? E is the point where it divides stator copper losses and rotor copper losses. So generally B to E, B to E is nothing but what? Rotor copper losses. To find the rotor copper losses, this is a total copper losses from the wattmeter reading under Blackwood rotor test. So this is the losses occur in the stator. Three times of, because this is three phase, three square, three into I1 square. I1 is the current in the I1 is the current in the stator, and R1 is the rotor resistance. Rotor resistance we should find from separate method is there. So we got that by using that one we can find R1, and we know this one, and this is 3 is the 3 3 phase. I1, how to find the I1? I1 is nothing but I1 is nothing but IBR. I1 is nothing but IBR, because the current, maximum current is flowing in the stator winding under block rotor condition. That is a maximum current in the stator under block rotor condition. That's why the maximum, this gives us maximum copper losses in stator. So this is the total losses in the stator. This is the total losses in stator plus rotor. So if you subtract stator losses from total losses, we will get rotor copper losses. We will get the rotor copper losses. In that way, we can find the rotor copper losses BR. So we can find a rotor copper losses. So if you get a rotor copper losses, for example, uh, 3 3200 watts, and how to locate, because this is in terms of distance centimeters, but this is in terms of watts. So to locate that distance in terms of centimeters, we should take power scale. So in the previously we took 1 centimeter is equal to 2.5 amps for current scale. In the same way we should find the power scale. So let us look at how to find the power scale. For example, this is BBR. This is BBR is the block rotor wattmeter losses, wattmeter reading. That is nothing but 2100. Nothing but B2F length. Look at this one. B2F length gives us total copper losses under block rotor condition VBR. That is how much? 2100. So 2100. B2F distance is nothing but how much? B2F distance is nothing but 2100. But by using graph, we can find the distance from B to F. So I assumed, but practically we should take that. If we should take from the graph, but I assumed that B to F length as 7 centimeters. So 7 centimeters is equal to 2100 watts. 1 centimeter is equal to 1 centimeter is equal to 2100 by 7. So we got 3000, sorry, 300. 1 centimeter is equal to how much? We got 300 watts. So power scale. So this is the power scale. But initially we took current scale as our wish, but we should take power scale according to the B to F distance. This is B to F distance. According to this one, we should take power scale. So this is the power scale which we took from the B to F distance. So that is nothing but 1 centimeter is equal to 300 watts. This is 300 watts. So now, so 300 watts. So uh, for example, this is the rotor copper losses. Rotor copper losses. For example, rotor copper losses is 900 watts. 900 watts. So to locate point E, so from this one we can locate point E. So this is 900 watts. From this one we got a rotor copper losses as 900 watts. So to locate point E, so this is the power scale which we have. So this is the power scale which you have. 1 centimeter is equal to 300 watts. So for example, I took out 900 watts. So we got from the from this one. So now 900 by 300 gives us 3 centimeters. This is the nothing but length from E F to E. So total length is how much? Total length is 7. So but BE length is 3. So that's in that way we can decide the E point. So in that way we can decide the E point. So this is a way to find the location of E point. And after locating point E from 3 centimeters and join AE. AE. A is A is the line which is nothing but a torque line, which indicates torque line. So why it is torque line? Which divides stator copper losses and rotor copper losses. Rotor copper losses is nothing but a torque. If the more current in the rotor, more copper losses, more will be the torque. That's why this is nothing but a torque line. Copper losses, full load, torque. So this is the procedure. Next point is, so for example, in the nameplate details, they will give 5 HP machine. Generally, 5 HP is nothing but 5 into 735.5 watts. So this is the output. HP is nothing but exact output after the losses. So HP, 5 HP is nothing but output of the machine, which is equal to, if you take the product 5 into 735.5, we will get 73677.5 watts. So from this one we should find the power scale. So this is the watts, but according to the, but we cannot show that watts in the scale. That's why I took in terms of scale. So that's why I divided with 300. So according to this one I divided with 300, so that we will get a distance of output. So how to draw the output length? This one, generally this never be 12 centimeters, but I assumed that one. That's why different values, different lengths will come. Generally 12 centimeters will not come. Generally 4 to 5 centimeters, generally small length compared to the previous one. So small length will come. So that length, how to draw that length? Nothing but from, because this is a point B is there, but here a different point is there, A is there. So for example, this is 12 centimeter. Practically 12 centimeter will not occur. Generally 4 centimeters I assumed. I got in the problems they will get 4 to 5 centimeters or some other. So the distance, how to locate this distance? So from this point we should take 4 centimeter upwards vertically. This indicates nothing but output. So this is nothing but net output value. These are the losses, losses. But this is to find the full load values. We should draw a parallel line to this is output line now. This is output line. We should draw a line in such a way that that line should be in parallel with the output line. This is we should extend up to the point where it is touching the circle, semicircle. So we should locate point L. We should locate point L. So this is the final step, and according to this one we can find any value. Okay, and to draw a vertical line up to this line, horizontal line from L to R, we should draw a vertical line. So this line is nothing but a torque line. So I remembered, I forgot to say this one. This is torque line. So why this is torque line? This is the line which separates. This is the line which separates a stator copper losses or rotor copper losses. Rotor copper losses is nothing but when the current flows in the rotor. When the current flows in the rotor, it experiences torque. If more current, more will be the torque. More current, more will be the torque. So that's why this line indicates that torque line. This line output line. This line indicates that output line. So we drawn a line parallel to the output line, and it is intersecting the semicircle here. So we should take this point. Okay, we should take this point. We should not take this point. And look at this one. KR indicates the no load losses. RQ indicates the, look at this one, RQ nothing but look at this one, extend this one, Q to E and R to F. This indicates the stator copper losses, and QP, this distance indicates the, so if you extend this P here and Q up to here, this indicates for, generally this one is rotor copper loss. In the same way, PQ indicates rotor copper losses, and AW indicates nothing but output. In the same way, PL indicates output. So let us clear that one, and let us recall once. So RQ, which is in parallel with RQ in parallel with EF, so which is equal to stator copper losses. In the same way, QP in parallel with QP in parallel with AE, which is equal to rotor copper losses, and PL in parallel with WA, which is equal to output. So this is the line. This line is torque line. This line is output line. So above this one is output. Above this one indicates output. That's why this line is output line. So above this one torque will produces. That's why this line is torque line. So if you want to find anything, we can if you want to find half full load, fraction of full load, different values of loads, different changes takes place. That's why we can find any at any value we can find the efficiency. Suppose if you want to find efficiency is output over input. Output is how much? PL. What is the input? Input is L2, K is the input. LK is the input into 100. This may be PL is the distance, for example 2.7 centimeters. Next to LK, this is LK is 3.7 into 100. We will get a percentage which is less than 100 percentage. In that way we can find efficiency, copper losses, net mechanical output, gross mechanical output, like that. And also the next one is how to find the maximum torque, maximum output, and maximum efficiency. Look at this one. So this is the torque line. Look at this one. This is the torque line. This is the torque line. So we should draw a line in such a way that that line should parallel with this one, parallel with the torque line, and that line should touches the semicircle. This is, look at this one, and which is 90 degrees. So this line is parallel to this one, parallel nothing but if we draw a line from this one to this one, that must be 90 degrees. This is end line indicates, this indicates that maximum torque. So how to find the maximum torque? This is n to this distance. N to this distance indicates the maximum torque. To find the maximum torque, this is the formula. So we know the power scale. So from this one to this one, we know the distance. So by using the distance, we can find the power. And 2 pi is constant. N is nothing but synchronous speed. Here this one n is synchronous speed. Power is nothing but distance. Suppose 3.5 centimeters is there. 3.5 into 300. So which we took earlier. So this is the power, and 60 constant, 2 pi is also constant, ns is from the data, so we can find the maximum torque. Next, how to find the maximum output? So this is nothing but output line. So I said earlier, this is the output line. So this is the output line. So, and if you want to draw a maximum output line, so draw a parallel line to this one, parallel line from OA to, the parallel line to OA is, look at this one, this is M. This line indicates what? Parallel to the this one which touches to the semicircle. So, and this indicates from M to P distance indicates nothing but maximum power output. Maximum power output, M to output. So this distance, for example, distance is 3.8 centimeters. We can find 3.8 into 300. This is nothing but a maximum power output. Next, if you want to draw the maximum input, so generally input is nothing but this is the input line, because stator losses, nothing but constant losses, rotor copper losses, stator copper losses, rotor copper losses, then output. So this combine the total, look at once. So this is the constant losses, these are the stator copper losses, this is the rotor copper losses, and above indicates the uh, output. So summation of all these is input. So that's why this line is, so this line OSG line indicates the hit input line. So in this way we can find the torque and maximum output and maximum input and if torque efficiency everything by using the circle diagram.